have a worksheet that you'll need to do that will be graded. I am not giving a quiz over what we learned, partial fractions and then linear optimization. I'm giving you a worksheet that it needs to be graded and done by Friday. And I will give that to you Wednesday or on Thursday. All right, so just got to get some definitions out of the way before we begin. Some examples. Let me explain what optimization is. You did learn this last year, but it's one of those lessons that probably goes in one ear and out the other. Because even my calculus students, I said to them, I'm like, we're doing optimization also. And they're like, no, we don't remember. So it's fine. But what it is, it's the process of finding a maximum or minimum value for a specific quantity using linear programming. And that's what you learned about last year. You did learn linear programming. She taught it to you right after you did the shading regions and inequalities. But let me explain truly, like give you an actual example of what it is. So if you go to a company, I mean, this is what they hire people to do. And you have to figure out the surface area, the best area to make a cereal box, the surface area, that would fill the maximum amount of cereal. That's an optimization problem. You're trying to figure out, how can I construct this cereal box? What are the dimensions of it that would fill the most within, like, using only 900 centimeters squared of paper or something like that. Okay, so it's optimizing what you have. You usually use it for profit, things like that. Now, let me just kind of quickly refresh you what you need when you do linear programming. Because again, this was something you should have done and remembered last year, but again, she does it one class. It's hard to remember everything. But linear programming needs the following. You need what's called an objective function. And they're going to give this to you in the first 2 or 3 examples. So, and it looks like this. It looks like f of x comma y would equal ax plus by plus c. They're going to give you the objective function in the first few examples. In the word problem part, you're going to have to figure out your own objective function, and we're going to do an example of that in a minute. Then you're going to have these constraints. Okay, and the constraints are a system of linear inequalities. So you would have like, x has to be less than or equal to 5, and then y is greater than or equal to x plus 3. They're going to give you a whole system of linear inequalities. So super fun. And what you need to find is called the feasible solution. The feasible solution is where that system overlaps. It overlaps in a polygon shape usually, okay? And you're looking for the XY pair or pairs. Now, we're going to work with one theorem today and one theorem only. And again, this is the theorem that you should have remembered from last year. I remembered when I taught at Algebra 2. Again, you do hear it, but it's just something that doesn't stick because we don't do it often enough. But it's called the vertex theorem for optimization. The vertex theorem for optimization. And I'm going to just draw it out here, and then I'm going to explain it, and then we'll write down the definition. But here's pretty much what the vertex theorem says. That when you draw this system of, linear inequalities, okay, and they all overlap right here, okay, so right here would be our feasible solution, right where that overlaps. The vertex theorem says, well, the actual max and min points are not in here they're actually located at the vertices, vertex. Okay. These, in this case, there's 4 of them. There might be 3 if it was a triangle, but these 4 points are where your max or mins are located. That's where the optimal maximum profit would be. That's where the optimal minimum profit, whatever we're looking for, minimum amount of surface area we need. So these are really the 4 points that we need. That's it. Those 4 points or 3 points, whatever. So write this little definition down. An optimal max or min, an optimal max or min value occurs at one of the vertices representing the feasible solution. An optimal max or min value occurs at one of the vertices representing the feasible solution. If you don't remember anything else from today, because most of what we're going to do is on the calculator anyway, all you really need to find are those intersection points, these points that create the polygon, and those 4 points will help you find the max or min into the objective function, is really all it boils down to. Okay? So we're going to do one example that's similar to how question 1, 3, I think 1, 3, and 5 are going to be, and then 7 and 10 are some word problems that you'll actually have to do tonight. When you do the word problems, and I know that they can get annoying, the least you can do is write down, like, look for some equation in there, write some equation, graph one of the lines, at least do something. Don't just leave it blank and be like, I don't know. That's not why you joined pre-calculus, just to say, I don't know, okay? You have to try. You have to start doing something. All right, so this is our first example, and this is the easier one. We are going to find the max and min, and we're going to graph. And they are going to give you the following things. They're going to give you this crazy looking function. And then they're going to give you this also, this system of inequalities underneath it. And I'll explain all of these to you, so that way you know what I'm talking about here. Okay, so all of this they're going to give to you tonight in the homework. This first thing right here, where it says f of xy, that is your objective function. That is what will help you find the max or min. Do not graph that. Do not graph that. I don't know how you would. Some people have tried. Don't graph it. Okay, that is your objective. Leave that for the end. These 3, what looks like 3, there's actually 4. These 3 are your constraints, and you are going to graph them. Okay, you do need to graph the constraints. Make sure they're all solved for y. This one's solved for y. This one's solved for y. These are x's. There's actually 2 inequalities in this one. Do you know what my 2 inequalities would be for this last one here? X is what? Here, I'll cover it up. Here's x is less than or equal to 4, and then x is greater than or equal to 1. So these 2 actually make up that last one. So I'm going to be really nice to you. I'm going to let you use your calculators. Go in your calculators. I'm going to kind of refresh you on how to do all this. Okay. If you have your Inequal Z app on already, which you should, mine's already on, so I don't know if you can see it. In order to change that symbol right there, I have to make sure my cursor is on top of it, and I have to hit alpha. Well, in this case, it is less than or equal to. So I'd hit alpha, and you change one of these bottom ones to less than or equal to. If you have those skinny calculators, you actually have to arrow all the way to the left and hit enter and then change it. I will help you out with that if you need me to in a moment. But type these in, please. X plus 4. This one's negative x. To do the x ones, you actually have to go into the x. So I'm going to arrow up all the way and go and hit enter. And I'm going to go into the X program here. Actually, greater than or equal to 1, and then this one's 4. These are x's. That is an x. That is a 4. Yeah. Okay, you can hit zoom 6 when you're done, and you should get a whole, my calculator, by the way, is so incredibly slow. I just want to let you know. It's going to be fast right now, but I'll show you when it gets to its slow point. But here it comes. There it goes. And there it goes. Okay. Now, this is really hard to see. Wouldn't you agree? Do you know that you can just shade the region? So do you see down here at the bottom, mine says shades point of interest? If you have the skinny calculators, you actually have to hit another sequence. I'll show you how to do that in a minute. But those of you that have one like me, hit alpha, y equals, and this thing comes up, hit number 1, which is inequality intersection. And then it'll actually do it again and just shade the intersection. If you have skinny calculators, hit second calc, and it'll say inequality intersection, I believe. And watch how slow mine takes. It will take forever, by the way. I'm going to graph it for you here. It's still going. It's still going. He sure is done by now. Like the black and white ones are so fast on it. Mine is terribly done. All right, now, there we go. Finally. Here's the whole point, though. What was the whole point of the vertex theorem? What do we actually want to find? The vertices. Okay, so how do we do that? These 4 points are the most important to us. So what you do is, again, do you see how the calculator says point of interest trace? And this is where it gets annoying. It really does. But hit alpha trace, or again, if you have the skinny calculators, hit second calc. I don't need this point right here that it gave to me, so I need to arrow around it. So I need this point right here. This is 1, 5. And then arrow to the right, 4, 8. And then I'm going to go down, I believe. 1, 2. And 4, -1. So now, those 4 points contain my max and min. How do I find my max and min? So it's really easy after this, once you get those points, 4 points, 3 points they might be if it's a triangle. You do f of 1, 5. You do f of 4, 8. You do f of 1, 2, and you do f of 4, -1. You're like, well, what does that mean? Well, that means, just so y'all are with me on this page, that means you take the value of 1 and you plug it in where? Into the objective function for x. So 1 would be -1 plus 4 times 5. And tell me what that answer is. That's 19, right? Then I do it again for 4. I plug 4 in right here. -4 plus 4 times my y value is now 8. And I get 28. Then I do 1 and 2. Then I do 4 negative. Put that into the objective function. That's where you use the objective function, only at the very end. So let's see. -1 plus 4 times 2. And then -4 plus 4 times. Now, out of those 4 numbers you got, which one is your max? The biggest number, 28. Which one is your min? -8. Now, a lot of you are like, couldn't I just have looked at this? Wouldn't that have made sense? Doesn't that look like it's on the backs? And that's, yes, it does. And yes, that does happen. So you can try that tonight, but don't always go with it. Sometimes it does change. Sometimes you have 2 maxes, depending on what the picture looks like. But do you understand this process here? You've got to graph it. You've got to find those intersection points. Then take those intersection points and plug them in and into the objective. That's all you have to do tonight. That's right there is 1, 3, 5 right there for you. Yes.
I thought max is like an X and a Y.
When we're talking about an equation that we're graphing, yes, but when we're actually talking about like these are actual values. We're going to do a word problem now. We actually want to know the maximum width. So you'd say 28, or something like 28 feet. You don't need to necessarily. We're just knowing a value. All right. Now take out this other sheet for me. The word problem. Yes, we all love it. Can't wait. We're going to do this one together. And then we're done. All right, so this says, mechanics at a repair garage carry two name brands of tires, United X and Royale Y. The number of Royale tires sold is typically less than or equal to twice the number of United tires. Right there, what does that sound like to you all? An equation. Let's write it then. The number of Royale tires sold is typically less than or equal to. Royale is Y. Less than or equal to twice the number of United. How do I write that? Beautiful. You just found one of your constraints. The shop can store at most 500 tires. This is another constraint. If my shop can hold at the most 500 tires, how do I write that?
Less than or equal to 500.
What's less than or equal to 500? You are right.
Y.
X and Y. Oh, okay. So there is another constraint. Due to the factory capacity, the number of Royale tires produced is greater than or equal to 50 more than 0.25 times the number of United tires. Again, sounds like an equation. So let's write an equation. The number of Royale tires produced, that would be Y, is greater than or equal to 50 more than 0.25 times the number of United. How do I write that? Yeah. Oh, you're doing it in such nice standard form. I'm not, but good job. All right. Last but not least, the garage earns $25 profit for each United tire and a $25 profit for each Royale tire. That is the objective right there, that they're earning a profit per tire. So our objective function is actually found right there, which is we're going to earn $25 in profit for every X United that we sell and $20 for every Royale Y that we sell. That is going to be how we find our objective amount of maximum profit. So write an objective function, list the constraints that model the given situation, and we're actually going to solve this together right now. So in your calculator, I want you to put these three constraints. Y is less than or equal to 2x. Do not put x plus y. Solve this for y. Y is less than or equal to 500 minus x. And y is greater than or equal to 50 plus 0.25x. Okay. When you put that in your calculator, by the way, please make sure that you have nothing in your x. I'm going to clear out my x right now because I don't want to have anything in here. It'll mess you all up. So let's see here. Less than or equal to 2x. Less than or equal to 500 minus x. And this one is greater than or equal to 50 plus. Now, if you try to graph this right now as is, because you have such a large number right here, 500, we actually have to change our window. And I'm going to give you that window change for you right now. So you're going to go to Window. And I want everybody to change their window so that the X min is 0. The X max is 400. And your scale is 50. And I want you to do the same for Y min and Y max. Don't worry about res. Don't worry about anything else. Y scale is 50. Okay, so change that for me. And then you can hit graph, and it should graph it nicely, I hope. I did it in the other class, so it took me a minute. We're here all year with my calculator. Come on, honey. Are you all done with your already? All right, there we go. It did work. Now, you can shade the intersection, but really, can't you just see where the triangle is at right now? I mean, I think that's pretty good. I'm going to draw it out for everybody just so we can see. So my triangle's looking like this, this, this. So I want to find this point, and this point. And again, I'm just going to hit alpha trace, and I hope it brings me up to 1. Yes. Now, these are going to be not fully whole numbers, okay? So this one is 28.57. So I'll call it 28.6, comma, 57.1. And I'm going to go around then this one up here is 166.7, 333.3. And then this one over here, let's see if I can, oh, bless you. There we go. 360.140. So now that I've found where those possible max min values are, how do I actually get the maximum profit? I take each one of these and plug it into my objective function. Now, we're looking for maximum profit. Which one do you think is the maximum profit going to be at? Where do you think? Just logically, right there. And you can plug it in and check and see. But if you plug it in, you will get the most amount of profit if they sold 360 X tires. Which one's X? United. And then 140 Royale tires. That would be your max profit. And you can multiply that out for me so we can see what we get. Let's see. 360 times 25 plus 20 times 140. So they would get $11,800 in profit just on the selling of tires alone. That would be their maximum profit. So pretty good. All right, so what's the whole point of this? And again, it's not a lot, but you're looking for your max and mins. You're looking to find out, the whole point is please get those vertices. Those vertices are important. That's where we can get all the max and mins. And then you plug that into your objective function, and that'll get it for you. All right. So this will be, you only got 5 problems for homework tonight.